హాయ్ ఫ్రెండ్స్, ఈరోజు మనం గ్యాస్ టర్బైన్ విత్ ఇంటర్కూలింగ్ గురించి చూద్దాం. గ్యాస్ టర్బైన్ విత్ intercooling. Okay. So we have already discussed that a major portion of the power developed by the gas turbine is developed by the compressor. Okay, that we know very well. So and then it can be reduced by compressing the air in two stages with an intercooler between the two. So this process, that means this improves the efficiency of the gas turbine also. Okay, so how we will fix that intercooler in between that compressor and here. Okay, we will see the okay, and now here we see the diagram, how to draw the diagram. First you can go take this thing, here is called low pressure compressor. First of all we can take, so this is called low pressure temperature, sorry, so low pressure compressor. So this is low pressure compressor, and low pressure compressor is passes through here. I am going to fix high pressure compressor, and then now here I am going to fix turbine. So then this is called turbine. Now it is going to fix generator. So this is called a generator. Okay, now where we are going to fix that intercooling is this low pressure compressor to high compressor. So high pressure compressor, in between these both compressors we are going to fix intercooling. Okay, and before going there, first we will see as it is the schematic diagram for this. Now here is called, we know very well, heating chamber. This is out, this is in. So this is called heating chamber. So then first it will come here, this is the point here. First high pressure compressor to heating chamber is called 1, and then that heating chamber to turbine is called 2. Okay, and then it passes through here, we know very well, intercooling. In and out. So this is called cooling chamber. This is one type of intercooling. Okay, and now here this to heat cooling chamber, turbine to cooling chamber, we called here 3, and then is going to move low pressure compressor. So here it will called as 4, process 4, 3 to 4. And then now here we are going to fix additional setup. These are we are fixed in here additional setup. So that is coming from intercooling. Okay, now this is the intercooling. Look at here, low pressure compressor, high pressure compressor. In between we are fixing with the intercooling like this. And then 1, 2, 3, 4 is the same process like a gas turbine. Okay, so this is the modification of this diagram. So this is called gas turbine with intercooling. Okay, and now the process of intercooling the air in 2 stages of compression. Okay, intercooling of 2 stages of compressors. Okay, so now you are going to see in here TS diagram, temperature and entropy diagram. And see here, first we are going to take first one. This is 1, 2. So now this is called 2, and then 2 to 3. So here we take, this is called 3 and this is pressure. Now we are going to see here where it will be touched. It will come like this is 0.5 and this is 0.4. And now this is 0.6. So now see this. This is the curve of this. I highlighted the lines. Two to 3, 3 to 4, and 4 to 5, 5 to 6. And this. Look at this highlighted. This is the curvature of this. And now 3 to 4, 4 to 5, 5 to 6, and then 6 to 1. Okay, and here we call, this is called pressures. 1, 2, 3. Now see here in this graph you can observe clearly T1 is equal to T5. At the same, similarly we can see in here also T4 is equal to T6. Okay, and then now here we see this is T2, and here that is a point is coming very near to close of this. You see this hidden lines is called T3. Okay, so this is the diagram of TS diagram. So here we see the process in here 1 to 2, the cyclic process here 1 to 2, heating of the air. That means here 1 to 2 heating chamber is entered. Then what happened? Hot air is entered and cold air is entered and hot air is outside, like that. Here is having heating chamber. So in this heating chamber, hot air in, cold air out. And then here we see then 1 to 2 is a air in heating chamber at a constant pressure. So here is pressure is constant 1 to 2. So then the process 2 to 3. Then here we can observe process 2 to 3 shows isentropic expansion. Now this is called a isentropic expansion. So this isentropic expansion of air in the turbine. Isentropic expansion air in the turbine. That is also nothing wrong. In previous cycle also like this. And then we are going to see 3 to 4 is have cooling chamber. 3 to 4 is source of cooling of the air in the cooling chamber at a constant pressure. Now here also see constant pressure. We know that pressure and previous same similarly here also constant pressure. And then here we see 4 to 5. Then here is coming from 5. Okay, and then here it will come 6. So 4 to 5 low pressure compressor. So what happened here? 4 to 5 shows compression of air in the low pressure compressor. So the process 5 to 6. 5 to 6 is, this is also same, shows cooling of the air in the intercooler at constant pressure. Finally process 6 to 1 shows compression of air in the HP compressor. Okay, so this is the process. Totally, this is the process to draw the TS diagram in here. So now we are going to see how to calculate work done. Then we are going to see calculate work done here. Work done by the turbine per kg of air. So then Wt is equal to Cp into T2 minus T3. So you can put this is equation number 1. And work done by the compressor per kg of air, that is called Wc is equal to Cp into T1 minus T6 plus T5 minus T4. So we can put it, this is equation number 2. Now the net work done is equal to W is equal to Wt minus Wc. So then this is called equation number 3. ఓకే, సో ఇక్కడ మనం గమనించాల్సింది ఏంటంటే the power available or net power of the installation may be found out from the work available as usually, and then the perfect intercooling, the intermediate pressure may be found out from the relation P6 is equal to P5, that is the constant pressure. Here we know very well this is constant pressure, P6 is equal to P5, and then now here that is equal to root of P1 into P4. So that is equal to root of P2 into P3. Then here 2 to 3, and this is equal. So equal means here we can take 1 to 4 directly. So that called here we can write this equation relation. So the perfect perfect intercooling, T4 is equal to T6. Okay, see here T4 is equal to T6, and then T5 is equal to T1. So T5 is equal to T1. Okay, so this is the, you can take the consideration points. Okay, now we are going to see one problem in here. A gas turbine plant consists of two stage compressor with a perfect intercooler and a single stage turbine. Okay, turbine only. Okay, if the plant works between the temperature limits of 300 kelvins and 1000 kelvins and 1 bar and 16 bar, find the net power of the plant per kg of air. Take specific heat at constant pressure as 1 kilojoules per kg Kelvin. Okay, we are going to solve this one. First we are going to take solution given. So here is T4 is equal to 300 kelvins is given, T2 is equal to 1000 kelvins, P3 is equal to P4, that is equal to 1 bar, and P1 is equal to P2, so that is equal to 16 bar. Cp is equal to 1 kilojoules per kg Kelvin. Okay, so now TS diagram, here we see the TS diagram. Let T1, T3, T5 and T6 temperature of air at corresponding points. So we know that for perfect intercooling, the intermediate pressure P5 is equal to P6, then that is equal to root of P1 into P4. So that is equal to 16 into 1. So here it will come 4 bar. Okay, this we know very well. P3 is equal to P4 constant pressure. Okay. At the same time, P1 is equal to P2 constant pressure. In pressure diagram, you see this is constant and this is constant and this is constant. Okay, pressures are okay, right? And then now here we see here, and in this problem in here we are going to see some same diagram for this. Okay, and I'm going to draw again here. For clear understanding, I am going to draw here. This is one. This is the process here. Okay, here is pressure is flowing. So now see here, point 2. 1, 2, 2. The pressure is having here 16 bar. 1, 2, 2 is equal to 16 bar. So then I can write here 16 bar. And now we are going to see here 2 to 3. Okay. And now we know very well this is equal to 5. This is having 4. This is having 5. And similarly, we know very well. Here is equal, this is equal, okay, and draw like that, okay. Next here, see this one is 300 and this is given in 1000. This is called 4 bar and this is called 1 bar. The process is going like this, we know very well, okay. So now this for process, isentropic process here, isentropic process 2 to 3. 2 to 3 is isentropic process, 5 to 4 is isentropic process, and here is 6. This is also isentropic process. Okay. So now we are going to take here, consider the isentropic process 2 to 3. Okay. So process 2 to 3, then we can write here T3 by T2 is equal to P3 by P2 whole power gamma minus 1 divided by gamma. So then 1 by 16. 1.4 minus 1.4. So then T3 is equal to T2 into 0.453. So here we know T2 value. Then calculate this. Here we will get 450 kelvins. That is called T3 value. Okay. So this is T3 value. Now here is S and here is T. Similarly, we are going to take isentropic process 4 to 5. Then here T4 divided by T5, that is equal to 0.453 P4 divided by P5 whole power gamma minus 1 divided by gamma. Then that is equal to 1 by 4, 1.4 minus 1 divided by 1.4. The value it will come 0.673. So then here we need to find T5. So therefore T5 is equal to T4 divided by 0.673. That is called 300 divided by 0.673. So this it will take 446 kelvins. So we know that for perfect intercooling T1 is equal to T5. Is perfect intercooling that is equal T1 is equal to T5. Then here 446 kelvins. Now we are going to see isentropic process 6 to 1. Then here we can write T6 divided by T1 that is equal to P6 divided by P1 whole power gamma minus 1 by gamma. Then substitute here the all values, we will get the 0.673. Then here we need, therefore we need T6 that is equal to T1 into 0.673. So that is called here 446 into 0.673. So then here answer it will come 300 kelvins. Okay, right. So now work done. Now we are going to find out work done. First turbine. So WT is equal to Cp into T2 minus T3. Then Cp is equal to 1, T2 we know, T3 we know. So the answer it will come 547 kilojoules per seconds, or otherwise kilowatts. And now here we are going to see compressor WC Cp into T1 minus T6 plus T5 minus T4. This is the equation. Okay, look at here, we take this equation, second equation, right? And then here substitute this all values in here. That is Cp is equal to 1 and T1 is equal to 446, T6 is equal to 300 plus T5 is equal to 446, T4 is equal to 300, and then now here close. So answer it will come 292 kilojoules per seconds. Now here net work done. W is equal to WT minus WC. So WT minus WC. Then here kilojoules per seconds. So the total power is equal to P is equal to 255 kilowatts. Now here joules per seconds is equal to watts. Since okay, so this is the procedure to solve the gas turbine with intercooling. And next we are going to see gas turbine with reheating in next class. Okay, thank you.